Hello everyone. This video would focus on conic section, specifically on ellipse with center at the point of origin or at 0, 0. And this is the sixth part. In this part, we're supposed to determine the standard equation of an ellipse given the coordinates of the two foci and the two ends of the minor axis. Before we go over this example, let's have a review on the parts of an ellipse and the two cases of an ellipse with center at 0, 0 or at the point of origin. We remember that there are two cases of an ellipse. The first case here is the horizontal ellipse. Before we go over this case, let's have the parts of every ellipse. The first part that we have here is the center. The center is halfway between the two diameters of the ellipse. The second part that we have here is the major axis. The major axis is the longer diameter of an ellipse that connects the two vertices passing through the center. So this means that both of these two dots that we have at the end of the major axis are the vertices. So one is the vertex and the other is the other vertex. The plural for that is vertices. So pretty much vertex is the end point of the major axis. Now we also have another diameter which we call as the minor axis. This is the shorter diameter of an ellipse that connects the two co-vertices of an ellipse passing through the center. So this point right here is a co-vertex of an ellipse, and this point down here is also a co-vertex of an ellipse. The next part of an ellipse is focus. So these 2 points right here are the focus of the ellipse. The plural for focus is foci. This focus is always gonna lie along the major axis. Please remember that foci of an ellipse are two fixed points on its major axis such that the sum of the distance of any point on the ellipse from those 2 points is constant. So those are the basic parts of an ellipse. Now we also remember that we have what we call as the semi-major axis. This is half of the major axis. So that means this runs from the center to the vertex, and we are going to represent this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, meaning this connects the center to one of the co-vertices. And this line segment from the center to the co-vertex is represented as letter B. Now, on the other hand, from the center to the focus is represented as letter C. Now, using these letters A and B, we can derive the equation of a horizontal ellipse. Now, using these lengths A and B, we can come up with an equation of a horizontal ellipse, and that is x squared over a squared plus y squared over b squared is equal to 1. Now, notice that our A is the longer value, because this is actually half of the major axis, which is the longer diameter. Now, notice that our A, which is the longer value, is the denominator of x squared. This means that if the denominator of x squared is bigger compared to that of the denominator of y squared, that means that we can come up with a horizontal ellipse. Now, we also remember that our A value, which is the semi-major axis, will always be greater than B, which is the semi-minor axis. That's always every time. And the equation that can be used to determine the length of C, that is from the center to the focus, is C squared equals A squared minus B squared. Now, let's look at the second case of an ellipse. For the second case of an ellipse, we pretty much have the same parts. The first part is the center. Again, this is halfway between the two diameters of an ellipse. We also have a major axis. This is the longer diameter of an ellipse that connects the two vertices passing through the center. Now, please notice that we call this as a vertical ellipse because the major axis is the vertical line segment. We also have the parts which we call as the vertex. There are two of them. We call them as the two vertices. These are the two endpoints of the major axis. We also have a minor axis, that is the shorter diameter of an ellipse that passes through the center and that connects the two co-vertices. And again, on this, along this minor axis, we have the co-vertices or the co-vertex if it's singular. These are the endpoints of the minor axis. Now, we also have another part which we call as focus. So these 2 points right here are our foci. So pretty much these are the parts of an ellipse. So it doesn't really matter if it's a vertical ellipse or a horizontal ellipse. The parts would still be the same. Now, we also remember that we have what we call as the semi-major axis. This is half of the major axis, which means this connects the center to the vertex, and we are going to label this as A. On the other hand, we also have what we call as the semi-minor axis. This is half of the minor axis, which means this connects the center to the co-vertex or one of the co-vertices. And we're going to label this as our B. Now, we also remember that the distance from the center to the focus is represented as letter C. Now, using these lengths A and B, we can therefore say that our equation for a vertical ellipse is x squared over b squared plus y squared over a squared is equal to 1. Now, notice that our a squared is under the y squared. This means that if the value under, or if the denominator under the y squared is bigger than the denominator under the x squared, we are able to get a vertical ellipse. And we also remember that, again, our A is always greater than B. Now, to determine the length of C, we are going to use the equation C squared equals A squared minus B squared. So these are the parts of an ellipse, and these are the two cases of an ellipse. Now, let's go back to the problem. Okay, going back to the problem right here, so we're given the coordinates of the two foci. So we have here 3 squared root of 5 and 0, negative 3 squared root of 5 and 0. If we change 3 squared root of 5 to a decimal version, this would come out 6.71. So I can go ahead and rewrite this as, so that we can go ahead and sketch this two foci. So 6.71, 0. So it's going to sit on the x-axis. So 6.71. So that's 671 should be somewhere around here. So this is our first focus. And then the other focus is 6.71 is somewhere around here. That's the other focus. Now, we also have the ends of the minor axis. So that is located at 0, 6. So it's going to sit right here. And the other one is going to sit somewhere around here as well. That's 0, negative 6. We remember that the two ends of the minor axis are actually the co-vertices of this ellipse. So I'm going to go ahead and write that down here. So these are the co-vertices of the ellipse, because remember, co-vertices are actually the endpoints of the minor axis. So we can go ahead and label this as our co-vertex, and this is our co-vertex as well. So that from here, we can go ahead and determine the center of the ellipse. We say that the center of every ellipse is the midpoint between the two vertices or the two co-vertices. So if we trace, again, we can use the midpoint formula to determine the midpoint between these two co-vertices, or we can trace it. The middle here is 0, 0. So this is our center. So I'm going to label that our C there. Now we see that our focus is on the x-axis. Therefore, this tells us that this ellipse is actually a horizontal ellipse. So I'm going to go ahead and write that information up here. Since this is an example of a horizontal ellipse, the general form for horizontal ellipse is x squared. Since that is horizontal, our a squared will be under the x squared, or the bigger value should be under the x squared. So that is a squared plus y squared over b squared equals 1. Since we already have the measure for the or the coordinate of the co-vertex, we can say that the distance from the center to the co-vertex is represented as letter B. So in this case right here, one of the endpoints of the minor axis will tell us the value for B. So our B, again, because the endpoint of the minor axis are actually the co-vertices. So therefore, we can say that our B is, if we count this, that is a 6. So that's a plus minus 6. And so we can go ahead and plug that value for B up here. So the equation is going to come out. Now, we don't know what the A value is, but we can tell that from this given value, our C, which is the distance from the center to the focus, is actually 3 square root of 5. So I can go ahead and write that down here, that our C value is 3 square root of 5. So that we can go ahead and use the equation C squared equals A squared minus B squared, because we cannot use this C and plug it in here. That's not how it's going to work, because we need the A. We can only get the A by using this equation right here. So we plug the values in. Our C is 3 square root of 5. And then we're going to square it, equals our A is missing. So I keep that as A squared minus our B is 6, and then square it. So this is going to come out. We square this 3. So 3 squared is 9. And then square root of 5 squared is just 5. So I can go ahead and write 5 there. And then A squared minus 36. We wanted the A, so we plus 36 from both sides. Before we do that, we have 45 equals A squared minus 36. So plus 36 from both sides, plus 36. So then we are able to get 81 is equal to A squared. So pretty much our A is plus minus 9. So I can go ahead and plug that in here. So this comes out 9. Our A was 9, and then square it. So then our final equation for this problem that we have up there would become, so this is the equation of this problem that we have up there. Now, we remember that our A is the vertex, so we can go ahead and plot that down here. So we go from the center, we go 9 places to the left and 9 places to the right. So this is where the first vertex is going to sit, and then the other vertex is going to sit on this side as well right here. So we can go ahead and write the coordinate of these two vertices. Okay, so we have determined the equation for this problem, and this is the graph of this ellipse that we have right here. Now, let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own, and when you're done, unpause it and check your answer. Okay, so we go over the problem here. So we're given this coordinate of the two foci and the ends of the minor axis. So we can go ahead and change this 2 square root of 7 into its decimal form, and then plot these 4 points on this graph. Okay, so what I did here was I plotted these 4 points. Now, we remember that the endpoints of the minor axis are the co-vertices. So I'm going to go ahead and write that down here. This is the reason why I labeled this as co-vertices for these two. Now, we remember that the center of an ellipse is located in the midpoint between the two vertices or the two co-vertices. So, using the midpoint formula, we can determine the midpoint between these two, or we can trace it. Our center here is at 0, 0, or the point of origin. So, I'm going to go ahead and label that as the center right here. Since our focus is on the y-axis, we can go ahead and say that this is an example of a vertical ellipse. So I'm going to go ahead and write that information up here. Okay, since this is a vertical ellipse, our a squared should be under the y squared. Since we say that this endpoints of the minor axis are the co-vertices, we can say that the distance from the center to the co-vertex is again represented as letter B. So we can go ahead and say that our B value from here is, we can just go ahead and count it. That's actually 6. So plus minus 6. And then we go ahead and plug this 6 into the B here. So the equation would come out. Now, we don't know what the A is, but we can get the value for C, which is the distance from the center to the focus, since the focus is given to us. So the distance between these two is 2 square root of 7. So I can go ahead and write the distance for C right here. That's 2 square root of 7. So this tells us that we can solve for A using the equation C squared equals A squared minus B squared. And once we have the A, we can plug it in here, and that would be the equation for this problem. So I'm going to show the work on how to solve for A. Okay, so our value for A is 8. So I can go ahead and plug that in here. So this is 8 squared. And so I will simplify this to determine the equation for this ellipse. Okay, so this is the equation for this problem that we have up here. Now, we say that our A is plus minus 8. That means from the center, since this is a vertical ellipse, I go up 8 and down 8. I'm going to go ahead and put that vertex up here and write the coordinate of the two vertices. Okay, so these are the coordinates of the two vertices, and I already have graphed this ellipse that we have right here. Did you get the same answer as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!